When you think of a desert, you likely picture a specific landscape, rolling sand dunes baking under a glaring sun. It's the standard image used in every movie, but it actually contradicts how scientists classify the biomes covering our planet. The scientific definition of a desert has nothing to do with heat. It is a strictly rain-based metric. Any region receiving less than 10 inches of annual precipitation qualifies. From that lack of water comes the secondary traits we recognize: extreme dryness and thin, sparse vegetation. Since the entire classification depends on moisture, the temperature of the air is technically irrelevant to the definition. Relying on the hot sand image makes it impossible to see the true geographic layout of Earth's harshest environments. When you prioritize rain over temperature, three distinct categories emerge: polar, subtropical, and cold winter deserts. This shift in perspective moves the focus away from the equator and toward the high latitudes. High-latitude environments, like these snow-covered plains, meet every scientific requirement for extreme barrenness and lack of fresh water. To accurately map the planet, we have to set aside our visual biases about what a wasteland should look like. We have to accept that the primary hazard of these regions is the absence of liquid water, not the presence of high heat. This chart lists the world's largest deserts by total area, and the rankings might surprise you. The top two spots are held by the Antarctic and the Arctic. The scale is massive. The Antarctic spans 5.5 million square miles, while the Arctic covers 5.4 million. These qualify because any moisture present is perpetually locked away in ice, creating a state of extreme, permanent aridity. Ground level in the world's largest desert looks like this: frozen mountains and ice shelves, where liquid rain is a rarity. While these are the largest contiguous biomes on Earth, their freezing temperatures place a hard limit on where humans can actually survive. The undisputed kings of the world's wastelands are made of ice, which makes the temperature-based model of geography obsolete. Now we can look back at the environments that actually fit the traditional mental model, the subtropical deserts. We have to reevaluate the Sahara and the Arabian deserts based on where they actually sit in the global hierarchy. On the chart, the Sahara takes third place at 3.5 million square miles, while the Arabian follows in fourth at 1 million. Humans have navigated and lived within these specific arid zones for centuries, moving between these rare oases. But unlike the frozen, static polar ice caps, the borders and boundaries of these hot subtropical zones are highly active. The Sahara's area has increased by over 10% since 1920, a process of expansion known as desertification. Seeing these zones as fixed features on NAT ignores the reality of their growth. This 10% expansion means millions of acres that once supported life have been swallowed by the desert. There is also the third category to consider: cold winter deserts. This includes mid-sized regions like the Gobi in Asia and the Patagonian in South America. These represent a unique climate trade-off. They have temperate continental weather and freezing winters, but almost zero annual moisture. This is what temperate aridity looks like: low shrubs clinging to dry, sandy hills in a climate that isn't a pole or a tropical zone. This proves that extreme dryness is a global phenomenon, not one restricted to the equator. Let's plot all three categories on a chart measuring temperature against area. The scale difference is clear. Freezing polar deserts sit far above the hottest subtropical zones. The remaining 7 major deserts cluster across the temperature range, but remain significantly smaller. Using this scientific model means giving up the simplicity of a single visual aesthetic. Real geographic literacy requires evaluating environments based on their core limiting factors, rather than just what they look like on the surface. For students and researchers, this framework clarifies the actual distribution of Earth's biomes. The data shows that polar environments dwarf subtropical regions in raw physical scale. For anyone looking to understand the planet more accurately, it's worth noting that the world's top 2 wastelands are made of ice, while the largest hot desert is actively growing. Shifts in the global climate will continue to alter these precipitation patterns, redrawing these desert boundaries over time. To prepare for a changing planet, we first have to correctly identify the forces that govern its harshest environments today.